Okay. So this question, count total number of colored cells when n is given. If n is 1, it is 1. For 2, it was 5. For 3, it was, I think, 13. Yeah. So what was the idea used here?
Uh, Basically, I started drawing this for 1, 2, 3, 4, and found a series like it's the sum of n numbers, and
Mhm.
those numbers are 1 plus 4 plus 8 plus 12 plus, like, just adding 4 to the last term.
Yeah. So ultimately, if we do drawing of one or two more patterns like this, we'll eventually see like what is the answer. So after this 5, 13, the next answer or the next count of cells came out to be how much? 25. So this is 1, this was 5, this was
Yeah,
13.
1 plus 4, then 1 plus 4 plus 8,
Yeah.
then 1 plus 4 plus 8 plus 12.
Yeah. So this became plus 4, and here it became plus 8. Here it became plus 12, and so on, right?
Yes,
Yeah. And after finding this pattern, you kind of just went and did a brute force.
yes, because I saw the constraint.
That's
So
what.
yeah, like running a loop for n times will not make, yeah, deal.
Because n में one में, yeah. So Piyush is suggesting to derive a formula and solve it in big of one. Yeah.
So like for each we can check how much we are adding
Yeah, it is 4 plus 8 plus 12 plus 16 and so on. So that was the addition.
so 1 2 3 like at 4 we are adding 16, right?
Yeah.
So 4 into I will tell us ki how much you need to add
Yes.
in from previous, and
At 1 we are adding 4 into 1, at 2 we are adding 4 into 2, at 3 we are adding 4 into 3, at 4 we are adding 4 into 4.
correct. And
At k we will add k plus 4 into k. This will give us the next
but this case
k plus 1
dependent
as term.
is this
This
case
is dependent on previous.
yeah
Yeah.
yeah correct, sorry.
So this is t of k plus 1 is equal to t of k plus this.
Yeah, this we can generalize, but this we can't.
Yes. So kind of ultimately it depends on the previous one. Yeah. So even I did, after coming up with the pattern,
Yeah.
just did a brute on this, and but yeah, that should lead us to a solution. Yeah. So here it was, you start with current and what is the factor we are adding, and with every term moving, keep incrementing factor and keep updating the current, and finally, yeah, that is the answer. Yeah.
One more approach I did in order of one for this.
Yeah.
If you go to the pattern,
Mm-hmm.
We observe like one pattern. Like for first cell, there is only one.
Mm-hmm.
And for second cell, there is a three we are getting extra.
There is a
Three, like middle box, three.
mm-hmm.
1, 2, 3. And for the third cell, there are 5 elements which are getting extra. If we observe in the pattern.
Correct. Then we'll get into
So
this.
what I did is like I used a natural sum formula. I
Mm-hmm.
found the sum of all the odd natural numbers, and then I doubled it and added the current value. I'll tell you. For second question, if you observe, there is 1 plus 3, 1
1
into 2 plus 3, 1 into 2 plus 3
1 into 2
plus 3.
plus 3.
For third one, 1 plus 3 into 2 plus 5.
1
1
plus
plus 3 into 2.
plus 5.
Yeah. For the next pattern, it will be 1 plus 3 plus 5 into 2 plus 7.
Okay. So ultimately it is odd numbers sum.
Yeah. We
1
can do
plus
it in order of 1.
1 plus 3 plus 5 into 2 plus 7.
Yes.
Okay. So then if we have to generalize it,
Yeah.
this was for n2, n3. So ultimately you are saying it will be for kth term, it will be 1 plus 3 plus 5, all up to k terms in total, right?
For nth term, yes, sir. N minus 1, it will be there.
kth term.
Yeah.
Or basically this repeats k terms of the sequence into 2 plus this is k plus 1th odd
Yes, A plus 1.
odd term.
If there are n numbers, then sum of n minus 1 odd natural numbers into 2 is n.
Got it. Nice. Yep. Yeah, this is good. Thanks, Hemant, for sharing that.
Yeah.
Yeah. Okay. Anybody else used any other idea, approach, pattern? No. Okay. One just additional point here. Sometimes for sequence problems, although this was an easy sequence to nail and solve, but for sometimes sequence problem, there is a site OEIS, which has all the sequences known available there. So sometimes when we are unable to find a pattern during the contest, knowing that site actually helps us. So have you seen that site OEIS? It is called some online encyclopedia of sequences.
Acha, if you type numbers there, right, it will give you formula like that something, right?
Yes, so that site is
Yeah.
there. Okay, my browser is stuck somehow. So that site is OEIS.
In
I'm
first
just
year I used to.
oeis.org or something.
Yeah.
So basically you type first 4 or 5 terms of any sequence, it has
Anyone is talking, I'm unable to hear.
No, bro, anyone.